Hello friends, welcome to Susan and John MathTube. In this video, we are going to learn about some basic problems in Ellipse. That is, we are going to learn how to find the center, the vertices, etc, etc, etc. And I hope you watched the last two videos in which we discussed about the standard equation to ellipse and the standard equation to the hyperbola. Okay, so first of all, the standard equation to an ellipse is x square by a square plus y square by b square is equal to 1. And I'm going to call it type 1 provided the value of a will be bigger than that of b. So that is my classification. I will call it type 1 provided a is bigger than b. I'm going to call the same thing as type 2 provided a is less than b. That means b will be bigger than a. Okay, now you have to know a few things which we derived in the last video in ellipse. So basically a standard ellipse will be symmetric about both the x-axis and the y-axis, and that means the center of the ellipse will be the origin 0, 0. You saw that in the last video. So first I'll write coordinates. So these are the basic coordinates that you must memorize. So the first thing is the center is the origin. So you can copy that. The center is the origin. And you saw that an ellipse or the same ellipse can be drawn with the help of focus and directrix on the left or the focus and directrix on the right. Okay, the coordinate of the focus on the right side is AE, 0. Do you remember in the derivation we found that the length between C and S is AE. Similarly, the focus on the left, the coordinate will be minus AE, 0. And the vertices, they are a, 0 on the right and minus a, 0 on the left. The equation of directrix, so basically you should know the foci together, plus or minus AE, 0. In some books what they do is they call AE to be C. Okay, so they learn like plus or minus C, 0. And there is one extra advantage for that. The advantage is it will be very easy for you to calculate the eccentricity using another relation between A, B and C. Okay, we'll come to that in a moment. Okay, now look at this. The vertices together, V dash together is plus or minus A, 0. So remember, the center is the origin. The foci is given by plus or minus C, 0 where C is AE. And the vertices are plus or minus a, 0. Now, if you want, you can by heart these coordinates. Okay, and if you want, you can by heart the end of the lattice rectum. But right now, don't worry about these things. Now, let's focus on the equations. Okay, basically, you have to understand the axis. The first one, axis of type 1 ellipses, the x-axis, so the equation will be y is equal to 0. Another equation that you have to by heart is the directrix. X is equal to plus or minus a by e. Of course, this one is plus a by e and that one is minus a by e. And you know the distance between C to Z dash, this is a by e, this is a by e. Okay, so if you want to by heart the coordinate, you can by heart it like what you call minus a by e, 0, and this one will be a by e, 0. And the next equation you should by heart is the equation of lattice rectum. X is equal to, so by the way, do you know what is a lattice rectum? Lattice rectum means it is a chord passing through the focus but perpendicular to the major axis. It is a chord passing through the focus, but it will be perpendicular to the major axis. So that will be and there will be two of them, one for the left focus and one for the right focus. So they will be plus or minus AE, because this distance is AE. Okay, so you can be good with these equations. And the next thing you should be very clear with is the length. So basically you should know that the length of the major axis. Major axis means the distance between V and V dash, and that will be equal to 2A. And can you see this? I'll call it B and B dash. So the length between B and B dash, and that is called minor axis. And you must remember the length of the minor axis is 2B. By the way, there is a relation connecting A and B. If you look at the derivation, we did it at the last of the proof. Do you remember we called A square into 1 minus E square as B square? Okay, so that's a relation connecting what do you call A, B and eccentricity. Now wait a minute, I told you in some books they use the notation C. So for them there is a huge advantage. What they do is they just open the bracket and they see that there will be this AE thing over here, that will be C square. So they learn the relation C square is equal to, you can see that C square is equal to A square minus B square. Okay, so that's it. So one more time I will tell you, you have to be very good with the coordinates. So we have our standard ellipse. You should know the center, coordinate of the center, the foci, the vertices, and if you want, you know, no one never knows where these things will pop up. So if you want, you can learn these coordinates, Z and Z dash, and that's done with the coordinates. And then you should know the length of the major axis, the length of the minor axis. By the way, the word semi means half. So if someone asks you what is the length of the semi-major axis, remember they are talking about distance from center to the vertex. And then I introduced a word latus rectum. Latus rectum means a chord perpendicular to the major axis but passing through the focus. Okay. So you have to write one more thing. The length of latus rectum, that will be 2b squared by A. So you have to understand this is b square by A and this is also b square by A, and the distance from center to the focus is AE. Okay, so I'll strongly recommend you can play the video from the beginning once more, but make sure you're like what you call 100% clear with the coordinates, the equations and the length. Okay, let's go for the basic problems. And remember, basic problems are the same problems which you learned in class 12 or maybe in class 11, etc. The question goes like this. Find, let's say, everything. And by everything, what I mean is, I'm a little bit lazy to write all those things. Center, focus, vertex, axis, latus rectum, major axis, minor axis, latus rectum, etc., everything. So the question goes like this. Find everything for the ellipse x square by 25 plus y square by 16 is equal to 1. So we are going to find everything for the ellipse x square by 25 plus y square by 16 is equal to 1. Okay, the first thing you have to do is you have to write comparing with the standard ellipse. Tell me, what's the equation to the standard ellipse? It's x square by a square plus y square by b square is equal to 1. So immediately you can write a square is equal to 25, b square is equal to 16, and if you want to follow the C method, that's also good, that's also great. If you want, you can follow the method c square equal to a square minus b square, and that will give you 25 minus 16, and that is 9. So we get the values a is equal to 5, b is equal to 4, c equal to 3. Remember, this a, b, c, everything stands for length, so always write the positive values. And I told you, for those people who use this C method, there is an advantage, and the advantage is in finding the eccentricity. Can you see the relation? Yeah. So they have the relation C is equal to A into E. So E will be C by A, and that will be equal to 3 divided by 5. Okay, so we have collected all these things. And by the way, those people who do not like this method, don't worry, you can use the relation B square equal to A square into 1 minus E square, and you can plug in all those values. What is B square? 16. A square is 25. And 1 minus E square, you can leave it here. And you can calculate 1 minus E square equal to 16 by 25. So E square will be, what do you call, 9 by 25. So you get E is equal to 3 by 5. See, we can start with coordinates. Okay, so the coordinates are, tell me what will be the center. Okay, 0, 0. By the way, did you identify this is type 1? This is type 1 because A is greater than B. Okay, so the center is 0, 0. The vertices, both the vertices, I am going to write together, plus or minus A0, and that will be plus or minus, okay, 5 comma 0. And the foci, if you want, you can learn like plus or minus C comma 0, or if you want, you can learn like plus or minus AE0. That's your personal choice, but the answer will be plus or minus, what is my C value, 3 comma 0. And that's the end of coordinates. Now you can write the equations. So what is the equation of the axis? Look at this, we have a standard ellipse. This equation refers to the standard ellipse. And if you have a standard ellipse type 1, the axis will be always and always the x-axis. So the equation will be y equal to 0. Now the second thing we need, the directrix. So the equation of directrix is given by x is equal to plus or minus A by E. The value of E is 3 by 5. So we get x is equal to plus or minus 25 by 3. Okay, now comes the lattice rectum, that will be x equal to plus or minus 3. Okay, finally the length. So the length of the major axis is 2 times A, that will be 2 into 5, that will be 10 units. The length of the minor axis is 2 times B, that will be 2 into 4 is equal to 8 units. And the length of the lattice rectum will be 2 into B square by 5. So that will be 32 by 5. That's it. This is how we find everything about the ellipse. So remember, in case you did not learn this in class 12, like what you call, this is very, very, very important. Then only we can move on towards like what you call better quality problems. So I hope you understood all these things. That's it. We have all the details about the ellipse. You can check it over here. Okay, so look at this. The center is 0, 0 as we found, and that is 3 comma 0 minus 3 comma 0, and look, the vertices are 5 comma 0 minus 5 comma 0, and we have the lattice rectum x equal to 3, x equal to minus 3, the directrix. That's it. So the length of the major axis is 10, and minor axis is like, look, 8 units, etc. So that means our calculation is correct. Okay, now let's go for another problem. So please write similar to the first question. Okay, find everything, and you know what I mean by everything. For the ellipse, x square by 64 plus y square by 100 is equal to 1. Okay, the first thing to do is you have to write comparing with the standard equation x square by a square plus y square by b square equal to 1. We get a square equal to 64, b 100, and I am sure that you already noticed here a is smaller than b. A is smaller than b. So this is type 2. So now I'll give you a trick. I'll give you a trick which will help you understand type 2. Now look at this. In type 2 what happens is, since b is greater than a, our ellipse will look like this. So this is also a standard ellipse, but the problem is the minor axis looks bigger than the major axis. Anyway, the trick is very simple. Change a into b and b into a in all the formulae which you learned in type 1. And that is why I told you type 1 must be in very good condition. So what we do is we change a into b and b into a everywhere in the coordinates, in what you call the relation, the equations, everywhere you change a to b and b to a. And the next thing you should remember is change x into y and y into x. And finally, in type 1, if you see a coordinate in the form alpha beta, you should make it beta comma alpha. I'll give you one example. In type 1, the focus or the foci were given by plus minus c comma 0. So in type 2 what happens is the foci will be 0 comma plus or minus c. By the way, I hope you read the instruction very clearly. Change a into b and b into a. There is no change for our eccentricity, and hence there will be no change for c also. Okay, now let's come to something more critical. The vertices. In type 1 it was plus or minus a comma 0. So in type 2 the vertices will be 0 comma plus or minus. Wait. What should we do with a? We have to make it b. Got it? Yeah. So remember the trick. Change a into b and b into a. X into y and y into x. And if you ever see a coordinate in the format alpha comma beta, make it beta comma alpha. That's it. If you see the coordinate alpha comma beta, make it beta comma alpha. We have the relation c square is equal to a square minus b square. So what we do is we should not touch c, but a will become b and b will become a. Now for those students who do not use this relation, b square is equal to a square into 1 minus e square, this will become a square is equal to b square into 1 minus e square. Okay, that's it. Now we are ready. Let's start. Okay, so the equation goes like x square by 64 plus y square by 100 is equal to 1. Clearly, we found that a square is equal to 64 and a is equal to 8. B square is equal to 100. So b is equal to 10. So we know b is bigger than a. So we identified the type. It is type 2 according to my classification. And don't forget the trick. A should change into b and b should change into a. X must change into y and y must change into x. And a coordinate system in the form alpha beta will be written as beta comma alpha. So if you are able to remember the three important points, you don't have to waste your time memorizing all the formulae for type 2. Okay, let's start with the coordinates. Center is still the origin. The vertices are 0 plus or minus b, and that will be 0 plus or minus 10. The foci are 0 plus or minus c, and that will be 0 plus or minus, I'm going to use the method c. What's the formula? B square minus a square. That will be 100 minus, that will be 6, 36, so 6. Okay, now, okay, I'm going to write c is equal to ae, so e is equal to, oh, that is not the relation. What should I do? C is equal to b into e. A should become b and b should become a. So e is equal to c by b, and that gives me c is equal to 6 by 10, and that will be 3 by 5. Oh, that's nice. Okay, now comes the equations. So what all equations did we learn? the first one, axis. So here in type 2 you can see that the axis is, now here in type 2 you can see that the axis is the y axis. So the equation will be x is equal to 0. Another thing, the directrix, earlier it was given by x is equal to plus or minus a by e. So in type 2 the equation will be y is equal to plus or minus, come on, think about it, plus or minus b by e. That is, y is equal to plus or minus b is 10 by 3 by 5. So that will be 50 by 3. Now if you want the equation to the lattice rectum, that will be y is equal to plus or minus 6. And finally, coming to the major axis, what is the length of the major axis? In type 1 it is 2a. So in type 2 it will be 2 into b, and that will be 20 units. And the minor axis will be how much? 2 into a, and length of lattice rectum will be 2a square by b. That's it. So that is a small video, and I hope you understood the basic problems in ellipse. So I'll be back with another video very soon, and in that video what we do is we will learn about the translated ellipse. Okay, so till then my friends, bye.